Right, so we've talked about Pythagoras' theorem being true. Now let's provide something interesting here. So if I have an angle in my triangle, theta, and I say that the hypotenuse is 1, I can always write the other two sides in terms of sine and cosine, because over here, the opposite side, it has to be sine theta, and the adjacent has to be cos theta. Now why is that? Well, that's because just by setting up the relation, I know, well, that's basically what it says, right? So remember that by definition, sine is opposite over hypotenuse. If the hypotenuse is 1, then this is just sine theta, right? If you want to do that, you know, in an exact logical way, say we don't know what the side is and call it x, set up the sine relation, so sine theta is x over 1. Well, solving this just gives you x equals sine theta. So in fact, it must have been sine theta all along, right? So yeah, and you can do the same for cosine theta. But given a triangle, or even a triangle of arbitrary length over here, let's call this r, right? If the hypotenuse is length r, and you know this is theta, then we know this must be r sine theta and r cos theta. So here we're sort of projecting the hypotenuse, the different components of it in terms of sine and cos. And that's a useful thing to be able to do in the mind's eye. And again, why is this true? For the same reason as before. Pretend we don't know this. Call it x. Well, I know that x over r is sine theta just by the sine relation. So solving that gives x as r sine theta, right? So that's useful to be able to do. But just going back to that first picture, let's just draw it in a slightly different way to keep things interesting. We have we had a 1 here, theta. Remember this, we can project that to be 1 times sine theta, so just sine theta and cos theta. Well, what does Pythagoras' theorem say if I apply it to this triangle? It actually says something pretty fascinating. You know, this is cool, right? The sum of the squares of these two sides has to be 1 all the time, at least for values of theta between 0 and 90. Now that's pretty weird identity, isn't it? So you can check that with certain values. If we plug in theta to be 0 degrees, I'm going to get 0 squared plus 1 squared. That equals 1 for sure. Another one would be, I guess, let's go with 30 degrees. So sine of 30 degrees is a half cos of 30. It's root 3 over 2. I can square both of these, and I'm going to get 1. So therefore, this is a very interesting identity to use. It's quite fascinating, really.